Question 9 is the good old cumulative frequency one. What you've actually got is a box underneath here that's drawn out pre for you that says cumulative frequency on it. So cumulative frequency, think of it as a snowball rolling down a hill. Alright, you start up here and it rolls down and it picks up snow as you go in. So it rolls through down to 10 and it's picked up 4. It keeps rolling then down to 20 and it's picked up another 18. Picks up another 24, that's then 46. Add a 40 on, 86. Add a 24 on, 110. And then a final 10, that's 120. So you've filled out your cumulative frequency table. Then from there, it's asking you to draw the cumulative frequency graph. Now what you've got to do is plot them at the top values. Alright, the top values here, because you're rolling through all the way through to 10 to get these 4. So we go in at 10 and we're plotting 4. We're going at 20 and plotting 22. We're going at 30 and plotting 46. And again, making sure you're accurate here. So each square, little square will count as 2. We're going at 40, and that's 86. At 50, 110. And at 60, 120. Then I've got to draw a curve. Now your attempt will be better than mine. Decided to do it on a computer, so it should be a bit better curve than what mine's turned out to be. So this bit should be a bit straighter, but you get the idea anyway. And then work out an estimate for the number of days which Lindsay drives more than 36 minutes. So 36 is 2 squares down from 40. So we go across. I'm just going to extend it ever so slightly because I think that curve would have been not as dipped. And then you read from here. Now the problem with this is it says more than, so it's not going to be just a simple read off and get 25 from there. It's how many more. But I've done this the wrong way around, haven't I? It's miles. See, this is what I'm saying sometimes. You rush things through, you make mistakes. So, sorry about that, I'll just delete that bit off. So the distance in miles is 36, so we go 6 squares along here. And then we go up. As we go up, then we go across. So our answer here is something along the lines of around 3 squares down from that, so going 2, 2, 4, 6, 6 off 80, which is going to be 74. 74 there. Now it's more than, so more than means that we've got here 120. So if we take 120 and then take off our 74, then that will give us what we expect, which is 46 on my one. The question is asking for 50. Now you can use the table if you wanted, but I prefer to read off there. 46, it'll give you an acceptable range, I think. So I think that's in the range. If you're getting nearer 50, you're closer than I was. And in fairness, it's possibly, if you're looking at where I've gone at the curve, my accuracy's not been the greatest there, so probably nearer 70 on that question. Question 10. Here are the ages of 15 women at tennis club, and I agree to draw the box plot for this information. So, first thing we've got here, I'm just going to bring these values in if I can. So they're the values there. So I'll just shift everything down a bit. So what we need to do is, for a box plot, we need to have our lower value, which is 16, so that's easy enough to put on there, so I can do that immediately. So it's 6 squares in, or 4 squares from here, so that's not a problem. And our upper value is 50, so they're easy enough to draw. Now we've got to find the median. Now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15 numbers. So to find the median, we add 1 and half it. So that will give us then 16 divided by 2, which is 8. So the 8th number, 1, 2, 3, 4, 5, 6, 7, 8. Our 8th number there will be the median. So 28 is the median. Now I don't obviously want you to draw this in with a ruler and not freehand like I'm doing. And then your lower quartile, make sure we've got 3 numbers and 3 numbers on this side, is 20. So we've got 20 there. And then our upper quartile, our 3/4 point, is 42. And then our box comes across. And we join our lines there. Now please use a ruler for this and don't do what I've done. So we've done that point there. Ticking all those points there for 3 marks. Then it says the box plot for distribution edges of men is there. Use the box plots to compare the distribution of the ages of these women and the distribution of the ages of these men. So for part B, what we're looking to do is just write down some information that we notice about these box plots. So what do we notice? Well, we can look at different things. Comparisons really. We've got median and we've got interquartile range that we can look at. So median first of all. The median for women we worked out was 28. The median for men was 36. So statement underneath, on average men are older. And then if we work out the interquartile range, so the interquartile range, the RQR for women is the upper quartile take the lower, so 42 minus 20, which is 22. And the RQR for men is 40 take 26, sorry 26, which is 14. And you can see now, because that range is smaller, men's ages are more consistent. If your RQR consistent there. If your RQR is small, it means that they're all compact. So the ages are a lot more squashed than what the women's are. There's a bigger range. In effect, the range we use there. So the ages are more consistent. Tricky question to answer that one. That's 10. Question 11. We've got a fact about 300 students. So I just put 300 here because I now know that all they have 300. Year 7, 8, and 9 boys and girls. Head teacher states a sample of 50 students. Work out the number of girls from year 9. So all we do, girls in year 9 are here. So we take, so year 9 girls, the sample will be 59 out of our 300 sample, and then we're going to times that by our sample size, which is 50. So if we do 59 divided by 300, times that then by 50, that will then give us 9.83 recurring, which then roughly equals 10 students. Question 12. So we have a histogram that's been drawn. Also we have a table that we could have a look at. So the table, actually I'll just leave the table off. No, I won't. Here it is. So we've got a histogram and a table. Use a histogram to complete the table. So we know certain information. First of all, here on this part we're given the whole information because we're given that the class width and the frequency. So what I can actually do is, if I go through my usual steps of doing the class width and frequency density, the class width would be 20, class width there would be 10, that'd be 10, that'd be 20, and that'd be 40. So we can work out the frequency density on the first one because it's 20 divided by 20, which is 1. So I now know the size of that is 1. So that'd be 2, that'd be 3, that'd be 4, and that'd be 5. So by using that information to complete the table, I've now got to work out 30 to 40. Now 30 to 40 is 10 times by going upwards here. So we're going up to 4.5. So because that's 4.5 there, if I do 10 times 4.5 times 10, that gives me 45 in there. And then the other one is 20 across, and it goes up to 3. So 20 times 3 will then give me 60 as my answer there. Then asks us to use a table to complete the histogram. So what I'm then going to do is get the other frequency densities. So 30 divided by 10 is 3, and the other one I've not done is 48 divided by 40, and that gives you 1.2. So we then draw the bars in. So this bar will go from 20 to 30 up to 3, and then this one will go from 60 to 100, and that goes up to 1.2. That's question 12 finished.